Good morning. It is Miss Siddig. This is my first geometry video since we have been self-isolated. So if you are at home and you needed some math, here it is for you. This will go into my Google Classroom and it is an optional video for you to watch. This is review from first semester geometry. So if you are in my class now, you already had first semester geometry, and this would be, this is good review as we go into second semester, because we'll still use some of these angle relationships. So if these were angles that you weren't 100% sure about, this is kind of a nice review for that. If you need anything, you have any questions, even if it's something unrelated to math, go ahead and leave me a comment, or you can send me a message through YouTube. That would be totally fine. Or you can obviously go into my classroom and send me a message if you need it. Today I'm going to talk about special angles on parallel lines. All right, parallel lines, hopefully you remember, are two lines that never cross. They have the same slope. They're generally equidistant all the way across. They are always equidistant all the way across. And what we're going to talk about is what happens when a line cuts through them. I'm going to call this line L and line M. And I'm going to say L is parallel to M. I don't know if you remember this, but when you talk about lines, you can name them based on their points. You can also name them using one small lowercase cursive letter. I'm going to have a line cut through here. This is going to be my transversal, and I'm going to call it T. Transversal just means a line that cuts through. It's going to cut through both of my parallels, and what happens is it creates special angle relationships. Now, I'm just going to number these. The numbering order doesn't particularly matter, so don't get caught up in like, oh, angle 1 and angle 4 are always this. It's going to be dependent upon how they're labeled because it's location that makes the difference. So I'm just going to call this one 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, there's kind of a cluster of angles up here, a cluster of angles down here, and what we find is there's going to be a relationship between these angles. Depending on how long this goes, I might do kind of an interesting floor model of this at some point, but for now, let's just do the board. Now, if you are familiar with vertical angles, you'll notice that if we look at just the top four, we have some vertical angles. Vertical angles are those angles that are formed by lines crossing, and they kind of look like opposite V's. Right, this is my symbol for vertical angles. Anyway, vertical angles are congruent. So for example, angle 1 and angle 3 are going to be the same size. Angle 2 and angle 4 are going to be the same size. Now that helps us because now if I know something about these angles and I can relate them to these angles down here, then I can tell a lot about the angles at the bottom. So let's talk about the first thing I think I'm going to talk about are called alternate interior angles. Now, once again, if you've taken geometry first semester before, this should be familiar. If it's not, that's okay. That's why I'm doing this. Alternate interior angles live in the parallels. So if I were to take and put my hands here, right, I'm looking for the angles that live inside my hands, that live inside the angles. So these are considered interior, and the ones above and below my hands, like above this hand and below this hand, are considered exterior. All right? So all of this area is considered interior because it's in between the lines. Now, if I took the lines and put them vertical instead of horizontal, the alternate interior angles would be here where my face is. All right? So this is still interior. Okay? That means anything above this line is considered exterior, and anything below this line is considered exterior. It's nice to do this on a smartboard because then you can highlight, but that's okay, right? We do what we can with what we have. Now, alternate is like in a team, right? When you are playing basketball, volleyball, football even, any kind of sport you're playing where you have like an area that's the court and an area that players that are not on the court are supposed to be, there's a line that lets you know, like in the game, out of the game, right? And when someone replaces you in the game, they're called your alternate. Right, when you go to state with a team, you're like, here's our 12 players, and then we have 3 alternates, all right? So this right here is the line that separates our players. These players will pretend they're outside the game, and these players are inside the game. Now, let me get a volunteer. Can I have a volunteer from the other room who is tall enough to be seen on camera? Okay. Now, pretend I'm angle 4. And my volunteer here is angle 3. All right, he is in the game and I am out of the game and we need to trade places, right? Now, watch what happens if I'm angle 4 and he's angle 3 and we try to trade places because he's my alternate. You ready? Go. And it did not work so great, right? So that was a bad alternate because what happened is when we tried to trade and alternate, we just ran into each other. Now, if I'm still angle 4 and he steps to the side here and he becomes angle 5, now when I want to go in the game and he needs to exit the game, watch what happens. Ha ha ha, we alternated. All right, so what happens is alternates are they're not directly next to each other. Thank you, volunteer. All right, when I'm in class, I usually have a student do it, but I don't like to a full body check like I did with him, but I married him, I'm allowed to do that. All right, 3 and 4 are not alternate to each other. They're both interior and they're next to each other, right? But they cannot alternate because what would happen is, as you saw, they run right into each other. So an alternate to 4 would be somebody who can cross the line so that they can each take their position. So 4 and 5 are alternate interior angles. Now, if the lines are parallel, then alternate interior angles, and here's the way you shorthand that, are congruent. So what that means is that 4 and 5 are alternate interiors, and because they're alternate interiors, they're equal to each other. So if I know angle 4's measure, I now know angle 5's measure. Okay? Now, in the alternate interior language, there's another pair that's going to be alternate interior. If I'm 3, who's my alternate interior? Well, the only one who's interior with me that hasn't been claimed already is 6. And 6 and 3 are at this kind of diagonal where they could pass each other without hurting each other. So 6 and 3 are also alternate interior angles. So I know angle 4 is congruent to angle 5 by alternate interiors. Good gracious. And then angle 3 is congruent to angle 6 by alternate interiors. Sorry, I keep putting a period and then trying to turn that into my I, which... Okay, so those are alternate interior. Alternate interior are only ever on the interior, and they are across the transversal diagonally from each other. Okay, so that's alternate interior. The next we're going to talk about are alternate exterior, which have that same sort of an idea, except they have to be exterior from each other. All right, so I'm going to leave the markings of interior, exterior. I'm going to leave the congruences, but I'm going to erase all this other junk. All right. Alternate exterior hold this same idea, but it's a little bit harder to see because there's more junk in the way. So let's start with angle 2. Angle 2 is an exterior. It is on the right-hand side. Well, yeah, as you're looking at it, it's on the right-hand side of the line. Sorry, the camera is backwards. Just bear with me. And if I'm saying it wrong, please forgive me. All right, it's on the right-hand side of my transversal. Okay. 1 is also exterior, but they're not alternates because if they tried to trade places, they'd smash right into each other. If you look at 8 is on the same side as 2 is, so they're not alternate. The only option would be 7, so you can almost think of it as diagonally, they're completely separated from each other. So angle 2 and angle 7 would be congruent because once again, if the lines are parallel, alternate exterior angles are congruent. Now, I also should include that they're cut by a transversal T, but I already have that written, so deal with it. All right, now, sorry, my arm erased 1 a little bit. So who would be an alternate exterior to 1 would be 8. Now, here's the trick. I just showed you all sorts of congruence in here, but we have more relationships. So alternate interior, alternate exterior. Interior, always inside the two parallels. Exterior, always outside the two parallel. Alternate is always across the transversal, but not directly next to. They have to be diagonal from each other. Okay? Now we're going to talk about same side interior, and then we're going to talk corresponding, because corresponding is one that is super important and shows up in a lot of places where you wouldn't expect it to. Alternate interior is also really important when you're doing four-sided figures, but corresponding is one that's just kind of cuckoo. Okay, so these congruences are still actual and factual. I guess I should have said before I erased that. Angle 2 congruent to angle 7, and angle 1 congruent to angle 8 by alternate exterior. Okay, now what I'm going to do is I'm going to erase everything but the numbers, and we're going to talk same side or let's see, they call it same side or consecutive interior. I like same side. I think it's more descriptive. But it's, it really just depends on the book you're using, what they call it. And I've worked in a bunch of different geometry books, and they've called it different things. So I'll refer to it as both. All right. Now, these are called same side interior, or they're sometimes called consecutive interior. Consecutive means in a row. I like same side though because I think it's more descriptive, especially when you're comparing it to alternate. All right, we're on the interior again, so I'm only looking at these. Now, same side does not refer to them being on the same side with the parallel. It means on the same side of the transversal. Alternate is alternate sides of the transversal. Same side is same side of the transversal. So if I'm looking at angle 3, for example, 3 and 5 are both on the same side. Now, this one, think about it as the idea, once again, of like a court. If this is my court line, 3 and 5 are on the same side. They're both on the bench. 4 and 6 are both out in the game, or whoever you like better, all right? But they're on the same side of the line, meaning that they have a relationship because they're interior on the same side. Now, they're not equal to each other, okay? If you have looked at four-sided figures before, then you've probably seen this relationship before. These two are not congruent. They sum to 180 degrees. Now, if I was a prepared human, I would have clear slide sheets that I could show you this with, but I don't have any clear slide sheets because I left them all at school. But what you can do, if you don't believe me, is draw one yourself. Then go ahead and remember, these two are congruent. So you could cut this out and you can slide it over to here to see that they form that 180 line. If we know what this one is, we know what this one is, they're the same, and these two are on a line that have to sum to 180. If this is something you're not sure about, I can do some more like hands-on video with it. Sorry, my apple's itchy. I can do some more like hands-on stuff with it if you want to see the actual physical, because sometimes it makes more sense to see it physically and not just on a board. All right, but so here, if L parallel to M, and sorry, I cut off my little T, then same sides sum to 180. So I remember it, it's the one that's the same side, it's the one that's a sum, all the rest of them are congruences. So I always think of it as same side sums, okay? I don't know if that helps you, but for me that sort of helps my brain. So I know that the measure of angle 3 plus the measure of angle 5 is 180 degrees by same side interior. And that's always true about same side interiors. Even if I were to turn this into a parallelogram of some sort, I still know that these two have to sum to 180. This is why it helps in like later situations. Okay, now my other pair of same side interiors are going to be 4 and 6. And they're not congruent to each other. They're on the same side, they're both out in the game playing, and they sum to 180. Okay? All right, so now I'm going to go ahead and I'm going to erase everything now. All right, but I want you to remember alternate interior are in the interior and they're opposite diagonally from each other. They're across or alternate sides of the transversal and they're equal. They're congruent, not all 4 of them, but the alternates are. Alternate exterior, same idea, alternate sides of the transversal, and they're congruent to each other. Same sides, sum to 180, and they're only on the same side interior, although you're going to find there's relationships through this whole thing. The last kind we're going to talk about are corresponding, and I'm going to go ahead and redraw this so it's slightly less messy, and we'll talk about corresponding. Now, I have to admit, in a perfect world, like I said, I would have a transparency that I could do this on. I'm trying to see if I have anything in my room, my office, that would like work for that, but probably at some point. So here's my parallel line again. Here's my transversal again. Okay. Now, corresponding come in fours when you're doing a picture like this. And it's like the word correspondent, right? If I was doing the news right now and I was like, let's see what's happening in Albuquerque. Let's go to our correspondent that's there. What would happen is they would start recording with the person that's there. We're doing the same job, right? But they're in a corresponding location. Now, that doesn't really give you a good description of where that is within the picture, but think about it as the idea of we're doing the same thing, all right? So what I think of it as is if I look at this as a four square, if I were to pick this four square of 1, 2, 3, 4 up, just yank it right off my page and smash it down right here, what angles would each of them land on? Okay, let me check and see if I do have a transparency. I might have one right over here. If I don't have one, we'll just get back to it. But you never know what kind of stuff you have hanging around your office as a teacher, just all sorts of rando things. Oh, that's so frustrating. I'm sure I have one, but I don't want to search too hard for it, which really sucks, but oh, you know what you could do though? If you happen to have trace paper would be a very good way to do this. One of my hobbies is sewing, and I've been making blankets and clothing and whatever during this sort of self-isolation time. Sorry, that's weird. Okay, and this is the start of a pattern for a skirt. I'm going to take and I'm going to put my trace pattern right here. Ha! Oh, geez, oh, please, oh. And what I'm going to do is I'm going to trace what's there. 1, 2, 2, 3, 4. And then I'm going to slide it down to these bottom 4. And what you see is it's the same picture, just down below, and what happens is my angle 1 lands right here, which is on angle 6. My angle 2, which was right here in that upper right hand corner, lands right on my angle 5. My angle 3, that was my bottom right, lands right there on the 8, and my 4 lands right there on the 7. So corresponding is they're the same angles in that same location, just shifted from 4. And what happens is they're congruent. So, sorry, sliding that did some erasing of my numbers. But what happens is 1 is in my upper left-hand corner. Therefore, 6 is in my upper left-hand corner. So 1 and 6 are congruent because they are corresponding angles. I should write that word, huh? 2 is in my upper right, so it's congruent to 5, who if you look at just these 4 is also in my upper right. The trick to this, I think, is trying not to look at all of them together. It's trying to look at them in this location and then picture them moved to this location. And that just takes practice. It can be really hard to do. Geometry for a lot of people is easy because of the visualization, but it can also be really hard because of visualization. All right, so 2 is congruent to 5. 3 would be congruent to 8 because it's in my lower right. And then 4 would be congruent to 7 because it's in my lower left. And that's by corresponding angles. Okay, now this was just a run through. I know it still was 20 minutes of information, but if you haven't worked with these angles in a while, or you found that you didn't really understand them when you took the class, or you found that you're like going to be rejoining a class soon and you're like, what were those angles again? Because they are going to come up. Here is kind of just a review of them. Okay, now, if you need anything, comments below. You can subscribe to my channel if you like. I will be posting this in my Google Classroom. And, you know, I will just keep an eye on what's happening. So hopefully I'll see you guys in a couple of weeks. I guess we'll see. All right. Take care. Bye.